Hi, I'm Jason Heiser at the University of Virginia, and today we're going to be doing a technology demonstration of Helix, and in particular the Kevlar portion of Helix that we've been working on transitioning from research into practice. To start off with, I wanted to just tell you a little bit about what Helix was. And so I've put up the architectural overview of Helix that we've been working on for years now with the AFRL. So Helix is a technology that allows us to take arbitrary software and provide a whole bunch of protections for the software. The protections we're talking about are protections from different types of attacks, such as code injection attacks. It's broadly separated into a variety of sections. We have proactive techniques that analyze and transform the program before it's deployed, and these store the results in an application information repository. This is really just a database of all the facts we know about the program. Once the system has been deployed, there's also the opportunity to do innate responses. Innate responses can detect that an attack happened, such as a code injection was attempted, and perhaps immediately respond to that attack, such as changing an encryption key that's used to encrypt the code. In a slower method of response, called adaptive response, we're actually going to have the ability to dig deep into what the fault in the program actually was, and possibly repair the program so that this type of attack is not even possible in the future. We separate this architecture a little bit into two different parts. The part that we're actually going to be seeing the technology demonstration of today is called Kevlar, and it actually involves the proactive actions and the innate responses. The adaptive responses that actually repair and fix the programs is called GenProg, and we won't actually be seeing any of that today. So I just wanted to give you a few of the key features of Kevlar before we get into the full demonstration of Kevlar and its abilities within Helix. So as I've already said, this is Kevlar is part of the Helix project that we've been working on at the University of Virginia with the Air Force for quite a number of years now. The key concept in Kevlar is that it has high entropy diversity that can stop attacks. For example, the instruction set of the program is encrypted, and it can change its encryption key metamorphically, and by metamorphically I mean as the program is running. So every few seconds the program will actually shift the attack surface by changing the encryption key. Likewise, the location of the instructions can actually change each time you run the program. The layout of the heap and the layout of the stack change each time you run the program. There's actually quite a few different possible diversity techniques within Kevlar. This is just a sample of them, but I think it's an important sample that provides a lot of protection. One of the other key features is that Kevlar works on binary programs. These are programs that have been compiled by the developer and shipped out, possibly on CDs or downloaded, and all you get is the program binary to work on. You don't have any source code, you don't have any ability to recompile the program, there's no specification for what the program could be. Kevlar is very efficient. Many programs show 0 to 10% slowdown, and so that's very usable. Most people will never even know that Kevlar is there unless they're trying to attack the program. There are some programs that have more than 10% slowdown, but in general we see that Kevlar is very efficient. And one of the key features of Kevlar that I think is important is that this is ready for transition to the real world. We believe that many of the techniques are between technical readiness level 5 and 6, and so that indicates strongly that we're ready to move forward with this and start getting this used in the real world some. So, as I promised, there's going to be a technology demonstration, so we're going to see Kevlar in action. What you see on the screen now is a picture of the laptop I'm recording this on, and I've already got Firefox open in the other window, and we'll see that in a minute. And in fact, I've already got it open to an email service, Google's Gmail service to be precise. And I've sent myself an email just to represent somebody sending you an email that you might get, and there's a couple of attachments in this email. There's two PDF attachments. The first PDF attachment we're going to go ahead and open. We're going to open it in a viewer called XPDF. This is Linux's most common PDF viewer. It is default on Ubuntu systems, very widely used, and this is an up-to-date version of XPDF. And we're going to open this PDF file we get in this XPDF program, and it's just a normal, well-formed PDF file, and so everything displays well and works correctly. The second attachment, we're also going to open an XPDF, but unfortunately it's not a well-behaved PDF file, and it's actually going to take over the system, take control of the system, and we're going to see that there's bad effects that can happen when you send this bad PDF file to the system. So, on to the demonstration. Let me switch to the window here that has Firefox running. So you see we've got an email here and there's some attachments. I'm going to go ahead and start by opening the first attachment, just like I said. So again, this is the stock XPDF that came with this system. I do want to be clear though that we modified it slightly. We inserted a security vulnerability in there. This is not a vulnerability that's in the stock distribution of the file, but we did add that in there. But this is a bug that could happen in any real-world software. It is a simple buffer overflow that have been plaguing security vulnerabilities forever. But XPDF still works pretty well. So we've opened the PDF file here. You can browse around. You can scroll. There's a menu you can use. I'm going to rotate this just so we sort of see that this is fully functional. Now again, this is just the stock version of XPDF, so this is somewhat expected that we can view good PDF files. But when I open the other attachment, now remember this is the malicious attachment, and I'm opening it again with the stock version of XPDF here. I just want to note that this is protected with state-of-the-art protections and state-of-the-practice protections. So hopefully this attachment can't cause it to do anything bad. Unfortunately, we get a message that says our system has been taken over, and it actually even displays to us part of the password file. And this is not the behavior you want out of viewing a PDF file in your attachment. So let's back up, and instead of opening these files with the vulnerable version of XPDF, let's go ahead and instead use the Kevlar protected version. So here we have the Kevlar protected version. And I'm going to open this up, and you'll see that there's no difference between the two versions on the good PDF. I scroll around, there's menus, I can use the menus. I'll rotate again just to show this is fully functional. And so on good inputs, this behaves exactly the same as before. That's spectacular. So let's now try the bad input, and we'll see if Kevlar is able to stop the attack. Again, we're going to use the Kevlar protected version of XPDF. So this is kind of interesting. Here we have a window and it says hello world. This is not the same behavior as before. Why is this displaying hello world instead of the password file that was, the attack was designed to do? Well, it turns out that Kevlar was actually able to repair the buffer overflow on the stack and actually executed the program correctly. And the PDF file generally says display the words hello world. And so Kevlar has actually repaired this program with its innate responses, and we're able to continue to use this program even in the face of attack. We've successfully used our moving target defenses to fight through this attack. So that concludes our demo, and what I would like to do here is give you just some pointers here. Love you to be able to go to the Helix website that's displayed on screen here. If you have any questions, that's a great place to start. Also, any of us in the project would be happy to answer questions for you. Dr. Davidson, Dr. Knight, Michelle Coe, and N are all happy to answer questions. And again, I'm Jason Heiser, and I would be happy to answer any questions you have about this as well. If you happen to have the Kevlar VM available, you can actually run this demonstration yourself. It's all there. The documentation shows how to run this. So I wish you luck. I hope you're able to do that, and thank you for watching.